Welcome to the video solution of your selected question from the Mathematics the Easy Way DVD. If you have not yet seen the introduction video on the DVD, please do so now, as it outlines how the Easy Way series will help students to be successful in their CXC exam. While the Easy Way video solutions will help to cement the understanding of certain special questions, the solution books are still absolutely necessary as they cover all the various types of questions that are set in CXC exams.
We are now at question 5 of the CXC CSEC June 2013 General Paper 2 exam video solution. And in part A, we are given this incomplete table and we are shown corresponding values of A and R, and we are told that A varies directly as the square of R. In other words, A is directly proportional to the square of R. And the first part wants us to write an expression of A in terms of R and the variation constant K. And since we are told that A varies directly as the square of R, it means that A is directly proportional to R squared. That's what this is. A is directly proportional to R squared. And if A is directly proportional to R squared, it means that A is equal to a constant of variation multiplied by R squared. And that's our expression for A in terms of R and the constant K. Now, based on the information here, we're going to have to complete this table. And to complete this table, we're going to need to calculate a value for A here. And we're also going to need to calculate a value for R. And in order to calculate these values, we're also going to need to find what that constant of variation is. And therefore, it makes sense to write down what K would be as a subject from this equation here. K would be equal to A divided by R squared. So when we are finding the value for K, we can use this formula. And we are also going to need to find a value for R, and therefore we can make R the subject of this equation, and so R squared would be equal to A divided by K. We divide by the K here, and so R squared would be A divided by K. That's what we have here. And so to find R, we would take the square root of both sides. And when we calculate square root, we have to consider positive or negative. And so R can be equal to positive or negative the square root of A divided by K. And so all this information is relevant. When we want a value of A, we use this formula. When we want to find K, we use this formula. And when we want to find a value of R, we can use this formula. And this is a good approach for variation question. Find each of the expression in terms of the other expression. Make each expression the subject. And that will assist us to proceed smoothly through the solution of this question. So let's move down to part 2. So what we have so far is that A as a subject is equal to K multiplied by R squared. K as a subject is equal to A divided by R squared. And R as a subject is equal to plus or minus the square root of A divided by K. And we still have the table here. Now part 2 wants us to calculate the value of K. And so to calculate the value of K, we want to be focusing on this formula right here. And that's what we'll be using. And so to find K, we have to use a known pair of values for A and R. And this is where we find that known pair of values. To find K, we have to use this known set of values. A is 36 when R is 3. That's what we have from the table here. When A is 36, R is 3. So by simply substituting for A and R here, we can find the value for K. And this is it. K is equal to A, which is 36, divided by R squared, that's 3 squared. And therefore, K is equal to 36 divided by 9, because 3 squared is 9. And then 36 divided by 9 is 4. So our variation constant, or our constant of proportionality, is equal to 4. Constant K is equal to 4. And that value remains constant, as it says, through the remainder of this question. Right? K is a constant equal to 4. Let's move down now to part 3. Now part 3 is telling us to complete the table. And so to complete the table, we want to fill out this cell and fill out this cell. Now this cell is a A value and this cell is a R value. And to complete the table, what we can do is call the value here P and call the R value here Q. And then we will complete the table by calculating the value of P and calculating the value of Q. And so we'll be using this formula A equals 4R squared, because we now have that K is 4, and so A is equal to 4 times R squared. And also we'll be using R equals plus or minus the square root of A divided by K. K is 4, so we'll be using this formula. R equals plus or minus the square root of A divided by 4. So when we want the A value, we'll use this formula. And when we want the R value, we'll use this formula. And so, firstly, to calculate P, we see that when A is P, R is 5. That's what we have. When A is P, R is 5. And as I said, we are trying to calculate a value, so we're using this formula. Using this formula and substitute those values. A is P, so A becomes P here. R is 5, so R becomes 5 here. And so P is equal to 4 multiplied by R, which is 5 squared. P is equal to 4 times 5 squared. And that calculation gives us 100. And therefore, P is 100. So the value for this cell is 100. And then we see here, we're trying to find the R value. And when A is 196, R is equal to Q. That's it. When A is 196, R is equal to Q. And because we're trying to find that R value, we can use this formula now. And that's what that is. We're using this formula to find the value of Q. So we can proceed by substituting the 196 for A here and substituting Q for R right here. And this is it. Q is equal to plus or minus the square root of 196, which is what A is, divided by 4. 196 divided by 4 is 49, and the square root of 49 is 7. And therefore Q is plus or minus 7. So Q can be plus 7 or minus 7. So here we can replace the P with 100 from here and replace the Q with plus or minus 7. Based on this strength, 3, 5, the next value we would expect to be in the table is positive 7. But because we were not given any quantification as to whether the values are positive or negative, we can use plus or minus 7. But I'm certain that in the exam, if you only place the value of 7 here without the negative, then you will also get your full marks. In any case, this is a complete table. Alright, and that's the answer for part 3 of question 5a. And so let's move down now to 5b. Now 5b is a functions question, and we are given f of x here equals 2x plus 1 all divided by 3, and we're also given g of x equals 4x plus 5. And the first part wants us to evaluate the value of f of g of 2, and the second part wants us to find f to the minus 1 of 3. So let's do this part first. Now f of g of 2 is the same as f of g of 2. That's what this is. F of g of 2 is the same as f of g of 2. F of g of 2 is the same as f of g of 2. So what we can do is calculate the value for g of 2 inside the bracket here first. Now g of 2 is obtained by substituting 2 here in the function g. And so g of 2 is 4 times 2 plus 5. 4 times 2 plus 5. And 4 times 2 plus 5 works out to 13, because 4 times 2 is 8, and 8 and 5 is 13. So g of 2 is 13. And now we are left to calculate f of 13. And f of 13 now is obtained by substituting 13 for the x value here in the function f. And so we can go ahead and show that 2 multiplied by 13, that's the x value here, replaced with 13, plus 1, all divided by 3. 2 multiplied by 13 is 26. 26 plus 1 is 27. So that's 27 divided by 3. 27 divided by 3 is 9. And therefore, f of g of 2 is equal to 9. And that's the answer for that part. Now here, we want to find f to the minus 1 of 3. That's the inverse function of f of 3. So first, what we can do is calculate f to the minus 1 of x. That's inverse of this function. Remember, the inverse of a function is obtained when the domain and the range interchange. When there's an interchange of the domain and the range. Now, f of x here represents the range of this function. X here represents the domain of this function. When the inverse is taken, this representation of the range, this f of x, becomes x, and this representation of the domain x becomes f to the minus 1, becomes the range of the inverse function, which is f to the minus 1. And so we can show the inverse of this function. The f of x here becomes x, becomes the domain, and the x, the domain in this function, x here, becomes the range in the inverse function, which is f to the minus 1. So that's a straight interchange of the domain and the range. And all we need to do now is transpose this equation to make f to the minus 1 the subject. And when we find f to the minus 1 as a subject, then we would have found the inverse function, and then we'll be able to substitute the value of 3. And so the first step would be to multiply the 3 over here, and then subtract 1, and then after that we would divide by 2. And so the f to the minus 1 will be equal to 3 multiplied by x, that's the 3x. Then we subtract the 1 over to this side, that's the minus 1 here, and then you divide by the 2, and that's how the 2 came here. And that's it. We can do that transposition in one step. Multiply the 3 here first, that's 3x, then subtract 1, so we end up with 3x minus 1, then divide by 2. And so we are left with f to the minus 1. And remember, it's an inverse function of x, so we can put in the expression for of x. So that f to the minus 1 of x is equal to 3x minus 1 divided by 2. That's our inverse function. And therefore, to find f to the minus 1 of 3, we simply replace the x here with 3 and also replace the x here with 3. And that will give us f to the minus 1 of 3. And that's it. F to the minus 1 of 3 is equal to 3 multiplied by 3. This x is replaced with 3. Minus 1 divided by 2 divided by 2. 3 is 9. 9 minus 1 is 8. 8 divided by 2 is 4. And therefore f to the minus 1 of 3 is equal to 4. And that's the answer for that part of this question. And that's the end of question 5. And we'll do question 6 in the next video. See you then.
You have just seen the video solution for a special CXC question, but this is only one of the many different ways that these questions are written. All mathematical principles can only be fully understood by solving many questions, and so I always tell my students, more maths equals better maths, and if they study hard, they will pass easily. All the various types of CXC questions are covered in the Easy Way Mathematics Solution book, and you need to practice every single one of them. Other books in the series are the Easy Way Multiple Choice Specimen book, the Easy Way Unit 1 Cape Mathematics Solution book, and the Easy Way Account Solution book. Please feel free to contact me with your comments and queries at any time.